Hey everyone, nice to see you. As you can see, I'm kind of in wishful thinking given our current frigid conditions here. So today it's going to be kind of an interesting exploration. So I started a couple months ago trying to understand how forehead thermometers work, and that led to thinking about how the fact that we all look really black in the infrared, and that led to understanding skin tone and melanin and stuff like that. And I've just discovered a lot of interesting other kind of fun facts along the way. I just wanted to share with you part of this exploration. So of course, our skin tone is determined by how much melanin we have. The more melanin, the more of this pigment we have, the darker our skin is. And the reason that that's relevant is that melanin is a very good absorber of ultraviolet radiation. So that means the darker the skin is, the more UV is absorbed, the less can cause damage, but also the less that we might need, that we might get, for example, to make vitamin D. So a lot of the things I'm talking about were based on an article that I read, shown here. So you can look at that if you want to have more information. And basically the premise of that article is that our skin tones are an evolutionary response to the ultraviolet, in that if we're in a place where there's too much ultraviolet, then we want to have more melanin to protect against that. And if there's not enough ultraviolet, then it's better to have light skin, less melanin, because then we can promote the production of vitamin D, which we need for health reasons. And we showed before that there's this correlation between the ultraviolet on the planet. So it tends to be more concentrated along the equator, and it gets weaker as we go either north or south of that, and pigmentation of people, so that the skin tone tends to be darker near the equator and then gets lighter as we go either north or south. Now, one exception to that are the Alaskan Inuits, who are quite far north, but nevertheless have relatively dark skin. And you might think that that would be a problem because then they're not getting enough UV and they're not making enough vitamin D. But it turns out that apparently they compensate for this by eating a lot of fish and sea mammal blubber, both of which are very high in vitamin D. So most of us only get about 10% of our vitamin D from food, but apparently the Inuits are able to do quite a bit better than that by their diet. I should also say that they only migrated north relatively recently, and that might not have been enough time for evolution to sort of kick in and cause them to have lighter skin, so that they can make more vitamin D in the lower UV. So, and a completely different story, we of course know that if you have too much UV, that will lead to melanomas and carcinomas, or skin cancer. And this is just sort of showing data that indicates that correlation between how much UV there is and how much incidence of carcinomas and melanomas. Now we know that melanin absorbs UV and therefore protects against getting melanomas and carcinomas, and so it shouldn't surprise us that pale-skinned European Americans have approximately a 10 times higher risk than African Americans for getting melanoma. We could look at the extreme case of that, which would be albinos who have no melanin. And in fact, if you're an albino who lives in Africa where the ultraviolet is very high, then in fact your risk of getting skin cancer is about 1,000 times higher than the rest of the general population there. So we need vitamin D for all kinds of health reasons, vitamin D which is synthesized by UV. And for example, it is needed in order for us to get calcium and phosphorus out of our food to promote bone growth and repair. It's also true that women need more calcium than men do, particularly when they're pregnant or lactating, both for creating bones and producing milk. But also it turns out that calcium helps to reduce this medical pregnancy complication, preeclampsia. And so again, it maybe won't surprise you to hear that quantitatively, females have significantly lighter skin than males. And so the argument sort of goes that with lighter skin, you therefore have less melanin, therefore you're absorbing more UV, therefore you can make more vitamin D, and therefore you can make more calcium. Okay, as another example, if you don't have enough vitamin D, then you are liable to get rickets if you're a child, or osteoporosis if you're an adult. So rickets is this medical condition that is mostly commonly caused by vitamin D deficiency, which leads to weak or soft bones in children and can lead to bowed legs. And so what we might expect is that if we look at higher latitudes where there is less UV, there will be less vitamin D uptake and therefore a higher incidence of rickets. And there was a researcher who explored a bunch of burial sites around Europe and found that indeed there was a correlation between the incidence of rickets in the children in those caskets and how far north they were. If we look at osteoporosis, which again is a bone condition that comes from not having enough vitamin D, then again at higher latitude where the UV is less, we would expect there to be less vitamin D in people and therefore weaker bones and therefore maybe a higher incidence of hip fractures. And there was kind of an interesting recent study that was done looking at hip fractures in Sweden as a function of latitude. And in fact, they found that for every degree north you go in latitude, there's an increase of 2 to 3% of having a hip fracture incidence. Now, it's important, however, to be clear about the difference between correlation, which is what I'm saying here, and causation. So correlation does not prove causation. So it is possible, for example, that as we go further north, there is more ice, presumably, and therefore maybe more slips, and therefore one might also expect there to be a higher incidence of hip fractures because of that, and not necessarily having to do with vitamin D deficiency. So this whole contrast between correlation and causation is really pretty interesting, and we might try and look at that another time. But for now, I hope you don't have to suffer any slips or hip fractures, between now and ever, basically. Okay, it's great to talk with you guys. Bye-bye.